Question. Prove by induction. If y is this, then there is this line. I do this question. So for n equals 1, the left hand side equals dy derivative dx. This equals d dx 1 over y minus 3x. This is y. Then this equals, we change the form of this. So this equals d dx y minus 3x to the power of -1. Then this equals -1 multiply y minus 3x multiplied to the power of -1 minus 1. Now multiply y minus 3x, the derivative. Then this equals -1 multiply y minus 3x to the power of -2 multiply -3. Then this equals negative multiply negative is positive. So at last, this equals 3 over y minus 3x to the power of 2. This is left hand side. And check the right hand side. Right hand side equals 1n is 1. This is 3 to the power of 1 multiply 1. The bottom is y minus 3x. N equals 1. So this is 1 plus 1. And this also equals 3 over y minus 3x to the power of 2. So the left hand side equals right hand side. The result is true for n equals 1. Now assume it is true for n equals k. So we have derivative k y dx k. This equals 3 to the power of k multiply k over y minus 3x to the power of k plus 1. We assume this is true. Then for n equals k plus 1, the left hand side equals derivative k plus 1 y dx k plus 1. And this equals derivative dx derivative k y dx k. Now we use this guy to replace this guy. So this equals d dx 3 to the power of k y minus 3x k plus 1. We change the form of this one. So this equals d dx 3 to the power of k multiply y minus 3x to the power of negative k plus 1. That equals 3 to the power of k. That multiply negative k plus 1 multiply 1 minus 3x to the power minus negative k plus 1 minus 1. Now multiply 1 minus 3x, the derivative. Then this equals 3 to the power of k multiply negative k plus 1. And here is 1 minus 3x to the power of negative k plus 2 multiply negative 3. So here negative multiply negative is positive. So this equals 3k multiply 3. The 3 is here. And multiply k multiply k plus 1. Now multiply 1 minus 3x to the power of negative k plus 2. Now this equals 3 to the power of k plus 1, k plus 1 over 1 minus 3x to the power of k plus 2. This is the left hand side. Now check the right hand side. The right hand side just equals, so here is 3 to the power of k plus 1 multiply k plus 1 over 1 minus 3x to the power of k plus 1 plus 1. So this equals 3 to the power of k plus 1, k plus 1, 1 minus 3x to the power of k plus 2. So compare them. So the left hand side equals the right hand side. Left hand side equals right hand side. So the result is true for n equals k plus 1. So the conclusion, the result is true for n equals 1. And if true for n equals k, it is also true for n equals k plus 1. Therefore, the result is true for all n belongs to positive integers by the principle of mathematical induction.